It is time to put our Ether channel into action, and what we'll do first is use 3 of the 4 ports available on each switch and put those in an Ether channel, and we're going to leave Fast Ethernet 04 out for now on both switches. We'll add it in later. And this is going to be the easiest, simplest, basic configuration you've ever worked with, because while we can do other things with an Ether channel, most of which you'll learn in future studies, right now we just want to build one, get it up and running, and you just need one command, and that is the channel group command. Now we do have to assign a number on each switch to the channel group, and depending on the iOS, the range of numbers can change. Don't worry about that for your exam. It's not going to go into that much detail. But what I really want you to know about it for now is that this value is locally significant only. It does not have to match the group number on the other side. So just to test that little nugget out, we're going to use group number 2 on switch 2 and group number 3 on switch 3. So let's go ahead and bring router 3 back up, and you can see that we are still trunking and all is well. And we'll just do one more test there since we took a little break here. And we're up and running. So let's go ahead and get started. We're going to use the interface range command to put these 3 ports into that channel group. There's the command. There is a little hyphen in the middle. And here, channel group numbers are 1 through 48. And I believe on the other switch, literally, you're going to see 1 through 6. So you have to get used to that in the real world as far as the numbers that are available. But right now, let's go ahead and just put 2 here, and then you do actually have to put the word mode in, and then you actually put which mode you want. Now, these 2 protocols that are mentioned here, LACP and PAGP, these are Ether channel negotiation protocols, and we're going to cover those in the last video in this section. I'll give you a few details on that, and we'll work with it, look at a couple of different combinations, but right now, we're going to go strictly with ON. And note the command creating a port channel interface port channel 2. We will come back to that. And right now, let's do the range thing. Through 3. Channel group, there are your numbers 1 through 6 on this switch. And you still have to put the word mode in, and we're going to go with on here as well. Now note the message here, creating a port channel interface port channel 3. And you actually will see messages that look like they're referring to the physical and logical state of port channel 3, but port channel 3 is a logical interface. It does not physically exist on the switch, and we will see it. You can actually check it with show interface and just follow it with port channel and the number. And if all is well, you should see up and up just like you would on a physical interface. And note what the hardware is. Because we haven't used the word Ether channel in a command yet, and it's going to be a little while before we do. But there is absolute proof that we are working with an Ether channel here. Hardware is Ether channel. So we're looking good there. We always want to verify. And the thing is, we've got a lot of different verification commands for Ether channels we can use, and we're actually going to go into those in the next video, I should say. Because right now I want to test a couple things we talked about in the very last video about ports leaving the Ether channel and also how STP looks at an Ether channel. So here on switch 3, let's run show interface trunk and compare it to what we saw just a few minutes ago. And look at that. Ports 1, 2, and 3 are now gone. And we have a PO3 for a port, which of course is port channel 3. The mode is the same, the end-cap is the same, status is the same, native VLAN is the same. But this is another good verification that we have an up and running port channel or Ether channel. So we have show interface trunk. What else could we run? He asked while typing the answer on the screen. Show spanning VLAN 1. And check this out. We no longer have ports 1, 2, and 3 here. They have been successfully bundled into an Ether channel. You see PO3 there for the interface. That's the root port. And yes, an Ether channel can itself serve as a root and probably will in most cases. But we also have the status, which is forwarding, and the cost, and less than half that of a fast Ethernet port. Pretty impressive stuff. So we're rocking and rolling there. We've got this on switch 3. Let's go ahead and take a look at switch 2 while we're at it. And we'll do a show, let's do a show spanning VLAN 1 there. Since this is our root, and you can see, again, ports 1, 2, and 3 have been bundled into port channel 2. and it's still a designated port, still forwarding. The cost has dropped to 9 because this particular logical port is so much faster than a fast Ethernet port, so the cost is reflecting that as well. So what I want to do right now is test the impact of a failed link by making one fail. So what we'll do on switch 2 is shut down port 1, which is one of the bundled ports, and then we'll run show spanning VLAN 1 again quickly and see what the result or the impact of that is. Let me wait for the usual suspects here. And you can see that there is an impact, but it's nowhere near the impact of when we had individual ports. Because what would have happened, especially if we were over on the non-root, is that the root port goes down, then another port's got to come out of blocking mode and go to forwarding. On switch 2, we didn't have that problem anyway because all 4 ports were already forwarding. But do note there's no interruption here, and the real key is the cost has come up slightly, because we don't have as much bandwidth available to us because we just shut down one of the ports. But the great thing is on either side, service is not going to be interrupted. Let's go ahead and reopen fast 1 on this side. And then we'll run show spanning VLAN 1. And we're good. We're back to the cost of 9. Let's go over to the non-root and work with that. And there we go, root port of 9. Let's shut down port 1 here. Let's see what happens. Should really be the same thing, right? And it is. The cost went up slightly. That is the impact. But on the non-root switch, of course, when we shut down port 1 before, when it was the root and that was it, then, of course, the port 2 became the root, but it still had to go through listening and learning, so there was a little interruption there. But here with an ether channel, we avoid that because STP sees the ether channel as one channel. It doesn't see it as the individual physical ports. So that is one reason we really like it. Let's do a no shut there. And we'll do a quick, now I'm glad that showed up. Hold on one second. Let's go ahead, wait till the interface comes up. This is a great real-world situation, really like that. So you can see now, Fast Ethernet 1 has come up, the cost has gone back down to 9, and everything's good there. But you notice that message we have right there, EC can't bundle. Fast Ethernet 1 is not compatible with 2 and will be suspended. Trunk mode of F1 is access, F2 is trunk. Well, that's when Fast 1 first came up. You can see this message sometimes when you first add a port to an existing ether channel, or also you see it when a port comes back online like Fast Ethernet 1 did here. So really just ignore it unless you keep seeing it, then something else has changed. But we can see very clearly that the port came right back and the cost went right back down to 9. Let's go ahead and add 4 here. And see if we get a little message like that. Doesn't look like it. But also notice now the cost has gone down to 8. So just to keep things even, we'll go ahead and chunk that down. And you can notice the cost has gone down to 8. So again, on neither side, when we took a port away or when we added a port, there was no STP recalculation as far as the port status goes. It's going to stay in forwarding mode. The only thing that really changes there is the cost. Now, we need to take a look at these verification commands I was mentioning, and we are going to do that in the very next video. See you there.